Hey everyone, hope you're all doing great. In this video, I'm going to talk about the solution to the problem that we have discussed in a previous video. Just to provide a brief recap on the problem state, we had a setup where multiple devices were connected to the AWS cloud and continuous metrics, application errors, events were sending to the Amazon cloud. And we had a use case where we have to process these incoming metrics using a CloudWatch subscription filter that feeds the data into a AWS Lambda function. And the Lambda performs filtering, processing, and then publishes that to the custom namespace um, by using an API called putmetric data. It's a CloudWatch API. And we had two operational issues. One was the subscription filter was directly invoking the Lambda, and due to the input events from the devices, and since we have had no separation between the CloudWatch subscription filter and the Lambda, um, the concurrency limit of the Lambda was exceeding available threshold. For account, we have the concurrency limit of 1000, and also the Lambda, which is helping us to publish the custom metrics by using the API, was observing a throttling from the CloudWatch service, as there is a limit of TPS of 5. So this was the problem statement that we had, and I have requested you guys to think about some of the solutions. I have seen a comment in the last video with using of a message queue, if I'm not wrong. Actually, that is a good suggestion. Let's going to perform a deep dive on how we can solve this problem. We'll try to see from where we can start solving this problem and ensuring that we do not introduce too much interest, because we have to keep the cost also in mind when creating a cloud solution. At the same time, we need some principles, especially considering that the metrics from the devices are important. We cannot afford to lose the data. So let's proceed. So some of the tenets that are important to solve this problem is one, the input events should be processed atomically. That means when we process the input event, we should we should not in a state where we process that immaturely, and we do not want a same metrics to be published twice. So either should be processed and published, or it should not be processed. So that's what I meant by atomicity. And of course, accuracy. We need to ensure that accurate metrics are published. And we should also think about the latency. Do we want a real time publishing of those metrics? What is the expected latency for the processing of these metrics? So all those things we need to think before coming up with a solution. And also the what kind of processing we need. Is it a real processing or a delayed processing? So based on this requirement, our solutions will also be changing. In this video, I'm going to talk about the delayed processing itself, and also we also want a flexibility in terms of configuring the parameters related to the compute, that is Lambda. So how throttling can be addressed? Let's going to target this problem first. So you might be aware about the strategy called as exponential backoff strategy. It is really useful when you're interacting with an API, and you are expecting some form of throttling from that service. So what this exponential backoff strategy? We try to interact with a service, and if throttling or some kind of client error or any kind of error, and we want some form of retry mechanism, right? So this exponential backup strategy mechanism, we try to make a call, and if you're facing some issue, we try to catch that issue or error in our exception blocks, and then we try to back off exponential. That means we take pause for like 1 second and then exponentially increase that, and we fix some form of number of retries. Let's say like max retries is 3 times. So we try to do that so that the service might be able to accept the request in those 3 retries. So that strategy can be helpful for us in terms of throttling as well. Whenever a client faces a throttling issue from the service, it can back off for a certain amount of time and then retry the request after some time. And another mechanism that can be helpful to reduce this throttling problem is batching, right? So batching instead of calling an API for every event, we'll try to group those input events into a single API call, and then we'll try to call the API. So this is going to reduce the TPS to the cloud. I think CloudWatch provides batch call of 1,000 input events, so we can combine all that into single call, and instead of making 1,000 individual calls, we can make a one call with all that input. So these two mechanisms can be really helpful for addressing throttling. But again, throttling isn't enough to solve the problem we have. We have a problem with concurrency as well. So you were able to solve the throttling issues to some extent, let's say by using batching of the metric events or even using the exponential. But if your input events are not controlled or not streamlined, you're going to have multiple concurrent Lambda instances. Again, this is what we have discussed in the last video, right? So if you do not have a way to control the input events, and you somehow created some mechanisms such as exponential backup strategy and batching mechanism, and let's say the Lambda is retrying the call to the CloudWatch API, and while it is processing, you're getting multiple other requests, and Lambda is concurrently calling the put metric data API. So this is going to go into some, exponential retry storm. So ultimately, it's going to cause the throttling. Again, batching also, there is a possibility of issues related to throttling. So we didn't solve the problem completely, but this is a good step forward for solving the overall issue. So these are the two strategies that we can employ to address the throttling issue. Now let's look into what can we do for concurrency, right? So again, it depends upon our use case. Do we want a real-time processing of the metrics, or are we okay to afford for some kind of delay in the uh, processing pipe? So in this video, we're going to talk about the with an assumption that we are provide some form of delayed processing. We are not in a requirement of real-time processing. Yes, so one mechanism we can use is coming up with some buffering layer. So what do I mean by a buffering layer? So currently, we do not have a way for the Lambda to aggregate the metric events that we are getting from the CloudWatch. We are getting the input events on a continuous stream, and then it's continuously get that. So the Lambda is not having a breathable time where it can process those metrics, aggregate them, and then come up with some efficient mechanisms, right? So we can think about some buffering layer where the metric events that we receive can be stored somewhere, and the Lambda can you know to look into that storage of metrics and then process those metrics, aggregate them, and then take some form of action. This is one mechanism which can help in reducing the concurrency, and even it decouple the input event publishing and the processing. We are decoupling the two layers. And another another method we can use to reduce the concurrency limits, and at the same time provide the flexibility of our compute parameters. So as I said, these are the tenets that we are going to base our solution, and we're going to go towards the solution, keeping these tenets in our mind. Right. So there is a very good pattern for achieving this. That is central router and sub workers pattern. So what we do, the central router will be a lambda itself, and the central lambda's work is to look into the storage where the metrics are stored, and it performs some form of processing logic as part of its, and then it groups the metrics in such a way that it is stacked to a specific metric type. Let's say from devices we get multiple metrics, right? There can be a crash related metric, some application errors. So what we do, for each type of metric we'll have a separate worker. Okay, so we try to group those metrics in the central router and push those to the specific worker. Now if application metrics are like of high volume, then we can think about increasing the lambda's cpu or lambda's memory, so that it gets more time to process those events. And if there is any other type of metric um, that has very less volume, we can configure the respective worker in the lesser configurations. Though this provides us a flexibility to control the cost of the infrastructure as well. It also helps us to um, employ this buffering layer. And when we are developing this kind of method, we should also think that the worker lambdas do not contribute to high concurrent instances such that it causes again throttling of put metric data API, right? So we should also keep that in mind because we are trying to solve the throttling problem. Also, we have to keep that in mind when we are designing this. We need to think about how many invocation events I can send from the central lambda to the worker lambda in such a way that these worker lambdas do not exceed the concurrency limits where it can cause the throttling issue of the CloudWatch API. So we need to do those calculations when we are employing this kind of pattern, right? And again, I said this is a delayed processing. We have to look into the timestamp of the metrics, and then we should try to backfill those metrics in the CloudWatch. The CloudWatch provides backfilling of metric for the past, in the past 2 weeks, and in the future I think one or so. It has that flexibility, so we can use the timestamp of these metrics and backfill those as per our processing. If it is too far enough, we can have use the current timestamp to record. And again, I talked about atomicity and accuracy, right? So we need to have some mechanisms to ensure that the aggregated events that we are having are processed atomically, that is only once, and published in at that moment itself. We need to have some mechanism to calculate that within the Lambda implementation, like whether a particular file can be processed within the amount of time that we have left in the Lambda. So this forward thinking can help us to ensure that accurate data is available on the dashboard, right? So this is how we can go ahead with the solution of the problem. Now let's look at the design of how it looks employing all this stat, right? So this is the design. So what is a new infrastructure I have? First thing is Kinesis Data Firehose. So this is a AWS service, fully managed AWS service that helps you control a continuous stream of data, and it has an option to deliver those data to a specific destination, like you know OpenShift, or I think Redshift is also available, and S3 is one of the destination of Kinesis Data Firehose. So basically, it helps you to control the speed of data. Amazon Kinesis Data Firehose also have this feature of buffering. So we can buff data, and at the same time we can configure the amount of time that we can buffer. Let's say my buffering size is 1 MB and buffering time is 1 minute. Whichever appears fast, that will be considered. So if I configure the Kinesis with buffering of 1 minute, whatever the events that we have received through the option filter, it will be converted into files of 1 MB, and then it will be delivered to the metric storage. So this in this way we are introducing this uh, buffering where we are trying to store the metric events at a storage in a safe place, and then we are having this central router which will be reading the events from the S3 bucket, and then it will help you to aggregate those metrics through some logic or implementation. Once it does all this implementation or processing thing, um, it will asynchronously invoke the worker lambdas. And here we are having a S3 payload bucket. So why are we having S3 payload bucket? So when you're trying to invoke lambdas with another lambdas asynchronously or synchronously, in asynchronous invocation we have a limit on the payload. So we cannot send more than I think 128 KB. I might be wrong in this number, but compared to the synchronous communication, um, the asynchronous payload is less. What is synchronous communication? Basically, we invoke a lambda and we wait for its response. So that is synchronous communication. In asynchronous communication, it's like a fire and forget method, right? So since we have this restriction of sending the payload through the asynchronous invocation, we are going to use a payload bucket here. So the central loader lambda will be processing that events and sending those payload events to the payload data to the Amazon S. And when we're trying to invoke the worker lambdas, we are going to send the S3 key corresponding to this payload bucket. So worker lambdas will be reading the payload bucket and processing those events, and it will be using the batching mechanism or exponential retry, all those mechanisms to publish that to the CloudWatch namespace, custom namespace. Here we should also think like when we should trigger our central route. We can even configure an event like, let's say, for every 5 minutes I'll trigger my lambda so that it will be reading my S3 files, and it also ensures that whatever the files that it is reading from the S3 are processed atomically. Like for every file, it checks the size of the file and the amount of duration that the lambda is left with, and only then it picks up. If it is unable to process those files will be still retained in the metric storage itself. So we are securely storing that. And as you can see, we have flexibility of configuring the lambda, because I can configure different values for worker 1, worker 2, and for central router lambda, which needs maximum amount of time to process, I can provide as a 15 minutes as the lambda duration. So this is the flexibility I was talking about as part of this design. Yeah, so this design is really good in terms of delayed processing, but if you want a real-time processing, there is another service called Kinesis Data Stream, where we have a mechanisms um, like routing the data to a specific channels. We call those as shards, and we can perform a event to destination mapping there. Like for each shard, when I say shard, you can think of it as a highway lane, where a specific highway lane can take only a certain amount of traffic. So these shards are like individual highway lanes that are capable to take certain amount of traffic, and we can provide some event destination mapping. In this destination can be lambdas, and we can limit there. So for real-time processing, Kinesis data stream would be a good choice. Also, there are some caveats to it. The amount of cost is going to increase, so we have to think about all those factors as coming up with this solution of real-time processing. Yeah, so this is the one of the solution maybe we can think of to process those events, keeping the tenets that we talked about in mind. If you guys have any other suggestions, or if you have any other different solutions for this problem, please do provide your comments and suggestions I hope you guys enjoyed the walkthrough. Please do like, share, and subscribe if you really like this content. I'm going to come up with more such problems, and we're going to perform a deep dive to see how we can apply the concepts that we learned theoretically and use it in our real world problems. So that's the idea of this channel. Yeah, thanks for watching. I'll meet you guys in the next video.